How did the best machine learning practitioners get involved in the field? What challenges have they faced? What has helped them flourish? Let's ask them. Welcome to Learning from Machine Learning. I'm your host, Seth Levine. Welcome. It's my pleasure to have Maarten Grootendorst to the show. He's the creator of many useful Python libraries, including KeyBERT and BERTopic. I've been an admirer for some time and really love using your libraries, so welcome.
Great, thank you for having me. Love being here.
So just to get things kicked off, can you give us a little bit of background just on your career journey, how you got into data science?
Yeah, of course. So I have a bit of an unorthodox background. I started out as a psychologist. I have master's degrees in work and organizational psychology and clinical psychology, and those were very interesting fields to pursue and very interesting work to be done. But I always felt like there was something missing, something, I wouldn't necessarily say factual, but a little bit more hard instead of the soft science that I was doing at the time. So I started to explore more the statistical side of things, because that's something that we do quite a lot in psychology. And eventually I rolled into programming and machine learning, and I figured, okay, studying in the Netherlands is relatively cheap, so let's do a master in data science. And that's where I found my passion, really. It's where I could find a true combination of psychology and still a technical aspect of it. Because much of what we do in data science, in almost all cases, involves some sort of human aspect. So that's where I really could make use of my psychological background. And then after that, I developed a few packages like BERTopic and KeyBERT, and did some writing and stuff like that.
Right. Yes, all those amazing, useful packages. So your background in psychology, do you want to just dive a little bit deeper into that?
Yeah, of course. I started out with a bachelor in social psychology, and that's rather broad, right? It encompasses quite a lot of different subjects. And my mother is actually an organizational psychologist, so I kind of had to follow her into her footsteps, right? No, but that was something I was familiar with, and something that I found to be interesting. And mostly the organizational psychology I thought it'd be really interesting. It's the human behavior in the workplace and how they relate with everything that happens on such a major aspect of your life, which is work, right? But at the time, I really wasn't, well, let's call it mature enough to really go into the field and do the stuff that was needed to be. I figured, okay, let's explore and develop myself a little bit further before I roll into my working life. And so I explored clinical psychology, where I could focus a little bit more on the, treating people that have, or helping people more specifically with anxiety disorders or depression or PTSD, things like that. And then, of course, you learn quite a lot of interesting things from there. But I always felt something was missing. Not that these fields are not interesting, but people like me always try to find their purpose in life, in a way, to find, okay, what makes me happy? Right. And although it was nice and interesting, I was quite sure that it wouldn't make me happy for the coming 30, 40 years. So you explore. And that's when I eventually found machine learning.
So when you first found machine learning, what was it that really attracted you to it?
The interesting thing about that is that because I was missing something more technical, that's one of the first things, of course, that attracted me to machine learning, because you can really, it's a new field, and there's a lot of technical basis surrounding many of these algorithms, but the way you use it and the way you apply it still requires you, in many cases, to have some sort of business sense. Some sort of view of, okay, when are we going to use this? Is it really necessary? Do we need a very complex algorithm, or can we use something relatively straightforward? And that puzzle, that's what it still is to me, that puzzle is really interesting, because there's so many small aspects to it, much more than just, okay, I'm gonna optimize the hell out of this algorithm, that really attracted me to it, and where I could find many of what I believe are my skills to be made good use of.
So when you were making, say the transition from psychology more to the technical realm, what was the first thing where you're like, these are the things that I need to learn first?
So as a psychologist, you're not the most technical person, right? You're focused on this, on interaction, human behavior, observational skills. There's some statistics in there, but the very first thing really is the basics, and that goes for me to 3-4 ways. So coding, of course. You can know an algorithm perfectly well, but if you cannot code clearly and well, there's bound to be bugs or issues or whatever found in there. That's really, really important to do that well. And for me, the second thing really was knowing the basics. Instead of going into very complex deep learning algorithms, it's really starting from, okay, how does a very simple regression work, which actually can be quite difficult if you really go into some of the complexities of it. So I was really focusing on making sure I understood that perfectly well, as much as for me it was possible, before going into the next steps, because those are the things that I found with my previous studies. The best way to learn is really, really understanding and knowing the basics. And if you have the basics really well done, like it's an intuition or something that you can do automatically, going into the next step becomes so much more easier. So that has been my focus.
Right. So just sort of creating the building blocks that could be the foundation for your future work.
Yeah, that's nicely worded. That foundation, the better the foundation, the better you can build on top of it.
Exactly. So having the creator of BERTopic, I figured that we should take some time to go into it. I'll let you give an introduction to it. If you don't mind, just talk about topic modeling a little bit and the power of it as well.
Yeah, sure. So BERTopic is it's now a framework for topic modeling, where you essentially have, let's say, 10,000 documents, and they can be anything, right? They can be reviews for a certain product, they can be tickets for a certain system, they can be multidisciplinary consultations for a hospital and some patients. And essentially what you want to do is you want to know, okay, what are these documents about? And there are many things that you can do. You can read all 10,000 of them, label them, which is perfectly fine if you have the time.
Take a little bit of time.
Just a little bit. Or you can do it automatically. And that's where topic modeling, of course, come in, because as the name implies, it essentially tries to extract topics from those sets of documents and tries to communicate them in a way that helps you understand what these documents are about, but also can help you do trend analyses to see if you have, for example, if you have Twitter messages, to see how COVID is being talked about 2 years ago compared to now. And it's a very nice way to extract that information, but because it's an automatic way without a ground truth, it also is very difficult to evaluate. So it's something that really fits with me as a psychologist, because it allows for a lot of human evaluation and interpretation of the technique. And you can use it for EDA, exploratory data analysis, just to see, okay, what do I have in my documents? But it's also used in a lot of socio-political science, where we look at certain information that has developed over the last few years and see how these trends have developed and changed for certain classes or targets or whatever.
Yeah. So I've been following BERTopic for some time, and I know, so version 13, 0.13 just came out recently. Yeah. I'm wondering, so the initial package, what was its goal? And then how has it changed, over how long has it been, say, 2 years, 3 years, maybe?
2 years or so, maybe almost 3 now. I'm not entirely sure, but it started out as a way to do to create a pipeline. Okay, so the pipeline of clustering and trying to extract a topic representation out of that has been around for quite a while. But I wanted to find a way to do it in a sort of pipeline where there's being made very little assumptions between the steps that you are using. So what we're essentially doing is we're transforming our documents into numbers, in numerical values, reducing that to smaller dimensions. So instead of 300 values, we're going to compress it into 5. We're going to cluster those documents, and from those clusters, which we assume to be topics, we extract the topic representations. And there's been a lot of pipelines that do that, but the way BERTopic initially thought of was making it in a way where you can say, okay, I'm not really happy with this clustering algorithm, and I'm going to choose something entirely different. Or I'm not happy with this dimensionality reduction algorithm, I'm going to choose something, again, different. And then the focus was mostly on the last part, on the topic extraction way. And I'm using a modified TF-IDF measure for that, called CTF-IDF. And because I initially thought of it doing that way, it was very easy to then devise many variations and extensions to BERTopic, which often are different packages. So in topic modeling, you have LDA, which is the classical topic modeling technique.
Yeah.
But if you want to use some sort of variation of that, you have to install a different package. In many cases, not all cases, of course, the GenSim has a lot of implemented already, but if you want to do hierarchical topic modeling or dynamic topic modeling, I think it's not implemented, and you have to install different packages for that. And what I wanted, and what it's now becoming, is a one-stop shop for topic modeling. Without necessarily saying, okay, BERTopic is the best ever topic model out there, which it definitely isn't. I mean, we still need to adhere to the no free lunch theorem. But you can use it for everything, basically. And because I focused on that pipeline of having minimal assumptions, BERTopic can now do hierarchical topic modeling, online topic modeling, class-based, semi-supervised, supervised, and a few others. And it will continue to develop in that way. So now what it currently is more focused on is build your own topic model type of package. And there are a few more things coming up, but so far that has been the trajectory for the last couple of years.
Yeah. Working in the industry now for a couple of years and doing topic modeling, I can say that I enjoy using BERTopic.
That's great to hear.
Just the level of abstraction where you don't necessarily need to know every single detail, and that you can get such incredible results. And also, as you were referring to, the modularity of it, where you can sort of plug and play and put in different algorithms to get different outputs. So you touched upon it before in terms of like evaluating topic models.
Yeah.
Can you talk about why it's so difficult to evaluate a topic model?
Okay, so what generally happens is you have, let's say, 10,000 documents, and they are tweets from some person or collection of persons. And what BERTopic or any topic modeling technique then is doing is, in an unsupervised way, so without a ground truth, is extracting topics from these messages, from these documents. But who's to say that these topics are accurate? And what does accuracy actually mean? So is it accurate to say there are 100 topics in those messages? Or is it more accurate to say that there are 10 topics in those messages? Is it more accurate to say that the way these topics are represented by a certain number of words, so the description of these topics, are they more or accurate than another algorithm? It also depends on actually sometimes the use case that you're working with. So sometimes we want more abstract topics because we're searching for global trends. And sometimes we're looking for very specific topics. So in the medical domains, we're often looking for very specific types of diseases or contexts or whatever, or medicine. All these types of different things make it very difficult to say, okay, this is the truth, because In this case, the truth often is truly in the eyes of the beholder. It's your use case. You have a certain goal for it, something that you want to do it, that you want to achieve with it. And what you want to achieve with it changes the evaluation metric. Because if we're talking a little bit technical, it can be accuracy, if you have labels. It can be coherence, so how coherent is a topic. But how coherent is a topic differs between what I think is coherent and maybe you think it's very different. Because BERTopic is a clustering algorithm, we can say, okay, we're going to perform the clustering, or we're going to evaluate the clustering. We can evaluate maybe its prediction on unseen documents, but that would be, again, a supervised task. There are a lot of different ways to find out if something is accurate, because the definition of accuracy here is so difficult, and that's why it's such a subjective way of modeling.
Yeah, I think the difficulty is that there's no necessarily like ground truth, right? You don't know what category or what cluster something should necessarily belong to, so it's hard to say this is how accurate this model is.
No, exactly, and the ground truth can be created, but it should each time be created from scratch depending on the use case, because I can create a ground truth for my specific use case, but then a ground truth for another use case will be entirely different and will sometimes require an entirely different evaluation metric.
What are some of the most unique uses of BERTopic that you've seen?
The most unique ones.
Or most interesting.
Most interesting. So the most unique ones are often the ones that try to do something with BERTopic that's not really meant to do. A lot of sentiment analysis people want to do with BERTopic, which
tricky.
It's tricky. You can do it if you do a sort of semi-supervised approach and code in the semantic nature of it and calculate that beforehand. So it is possible. But what I mostly see are a couple of things, and that's trend analyses. But what has becoming a little bit more and more popular, and I found that to be really interesting, is so initially I always thought topic modeling was something not used in production, right? It's an exploratory way of looking at your data. But I'm seeing many more cases popping up that are focusing on trying to identify clusters on the fly. So if you have a ticket system, for example, and you want to see if there are some issues that are popping up daily, yes or no, then you can use an online variant of topic modeling for that to see if new issues pop up over the couple of days, so you can quickly fix the issue that you have. And that's something that I developed, I think, half a year ago, because I saw more and more use cases popping up where they say, okay, but what if I want to use it on not only unseen data, but unseen data that have different topics than what it was initially trained on?
Right.
And that was, for me, a really interesting use case that I hadn't seen before.
What are the techniques that are used to do that, to find new clusters over time?
So there's one library, I think it's called River, that mostly focuses on that part of online clustering or machine learning approaches in general, but that also allows for newly information to be found. So scikit-learn often focuses on not finding any new topics or new information necessarily, but to continuously train the model, and that's a valid use case. But River, for example, focuses a little bit more on the not the true online aspect of it, but more finding something that we haven't found before. Right.
So over the 2-3 years of developing BERTopic, maybe not the top, but what was one of the most challenging things that you faced?
So dependency issues.
You're using Python.
It's way more tricky than I had thought before. So I have a couple of packages, and some are more easier than others. But there were a lot of ABI issues with NumPy that were really tricky to solve. And over the course of time, it remains an issue because dependencies change, of course, and it's in a way it makes sense that they change. I also change the API now and then. So things break, but they can sometimes be really, really tricky to fix and to find and to account for because there's so many combinations of dependencies out there. That's just tricky to account for all of them. So that's one issue on one hand, and the second one is mostly API development. Not necessarily algorithms. I find them fun. They're still difficult, but it's not really an issue, right? But the API in itself is something that people are using daily. And if you change that in a major way, then everybody has to change. Things that work now in production will stop working. So it has been really tricky to think about these things in a way that accounts for anything that I might want to change in the future. Which is, of course, not possible because I'm thinking of changing Plotly with bokeh now, and that's going to be a pain in the ass to do.
That's going to be tricky.
But there are a lot of more things. If I want to, so now you pass in documents, right? But at some point I want to pass in images and sound and whatever.
Right.
That requires major API changes, which is difficult to do in a way that doesn't annoy users because they're using it quite frequently, and if you're going to change it dramatically, it's not the best user experience. So those things actually were the most difficult.
Correct me if I'm wrong, but I was reading one of your articles on Medium, and you were talking about this sort of decision about breaking dependencies. Sometimes there's a time when it's okay, and then sometimes maybe there's a time like when you shouldn't. I don't know. Can you just speak a little bit more to it? How it could limit you sometimes?
I'm trying to think of what you're referring to, which article it was, and what I exactly said in there. But what often happens is when I want to develop features or want to implement something new, what often happens is that I have to introduce a new dependency, and that's really something I think you should prevent as much as possible when developing a package. BERTopic already has quite a number of dependencies, and I would have just had 3 if in a perfect world, which of course doesn't happen. But the moment you add another dependency, the interaction between everything can mess everything up, because it essentially gives you another layer of complexity when accounting for all of these dependencies. So when you're doing topic modeling, a natural package to add to that is network X, for example, to show some sort of network relationship between the topics, which would have been really fun to implement and it's definitely doable, but that would require to add another dependency that might not work well together with the ones that I already have. And I did some covariate topic modeling for BERTopic, which I really want to implement, but that would also require me to add the stats models dependency, which is a great package, but it's another dependency. So I can easily create a list of 20 additional dependencies to add, and then at some point BERTopic will not work anymore. Yeah, so it's unfortunately it's a balance between those packages that you want to add or not.
Right, weighing those trade-offs, trying to keep things as lightweight as possible.
Yeah, exactly.
While balancing, additional features and things like that.
Yeah.
You also refer to something called the psychology of APIs. Do you want to just talk about that for a minute?
Yeah, so that's what happens with me, right? I'm extremely biased with my background in psychology, so I call everything the psychology of just because I want to.
You can get away with it.
Great, then I'll keep doing that. But the thing is, like I mentioned before, when you're doing API design, it's about the way people interact with your package, with your model, with your software. So then changing it dramatically hurts the user experience. So there's a lot to be learned from popular API design out there, like NumPy and scikit-learn and pandas, where people at some point have developed a way of coding in Python because of those packages. And if you try to adhere of the philosophy in the design of those packages, even when designing something new, you're focusing really on the psychology of the experience. Because if you do everything in the scikit-learn type of way, that's really nice because everybody knows scikit-learn and it feels intuitive when you then approach such a model. And the same applies when you're creating a package. It doesn't necessarily need to adhere to scikit-learn. Whenever you create a new parameter, what kind of name are you going to give that parameter? What is intuitive? Even the position of the parameter can be very important because sometimes people don't want to create keyword arguments. They just throw in the variable, right? So then the position is really important when designing the package. And there's a lot of these types of things that you need to take into account when developing a package because, well, people are going to be using it. And if people are going to be using it, okay, then there's definitely some sort of user experience, psychological aspect of it out there where you can really make a change when it comes to the adaptation of whatever it is you have created.
Yeah, it's such an important thing to be thinking about when you're creating something because who's the consumer, right? You always need to be thinking about that. What are the most exciting future directions for BERTopic that you're most excited for?
So I mentioned that briefly before. I'm thinking of changing Plotly with bokeh, and I'm not doing that because I hate Plotly. Plotly is awesome, and same with bokeh or Altair or whatever. It's just I want to add images at some point, which I've already done with a different package called Concept that tries to integrate documents and images into one topic modeling approach. And I want to eventually do it also in BERTopic, but in order to do that, when you're going to visualize your data points, you typically also want to visualize them, the images, and that's not possible directly in Plotly. You need to use Dash on top of that, which that's not something that I'm a fan of in when it comes to the psychology of API design, right?
Right.
That changes the way you interact with the visualizations quite drastically. So I'm thinking of changing it to bokeh because that allows you to do a little bit more with images. And when it comes to interesting future directions, is because we have more multimodal embedding types of models. We can do documents, images, sound, all in the same dimensional space. So if you can do that all in the same dimensional space, then there's something to say for topic modeling also going into that direction. But there's just a little bit more to think about than just the embeddings, also the topic representation, extraction, and the way you connect the images together with the documents and perhaps sound at some point. That's something I have to dive a little bit deeper in. I have some code lying here and there, but I think there's also much to be gained there. Yeah.
Awesome. Yeah, I'm glad that we got to dive into BERTopic. It is absolutely one of my favorite libraries to use. Just to switch things up, we can just talk about machine learning in general. Such an exciting field. I'll start off with this. What's an important question that you think remains unanswered in machine learning?
So there are a few, of course, but there's one thing that has been popping up quite often lately, and it has to do with, of course, the ChatGPT type of approach. Is what happens when such a model gets released is that people are starting to talk about AI as if it were artificial general intelligence, right? True intelligence, true consciousness, true it can pass a Turing test. Those types of exclamations that were made, those types of. And the thing is, that's something that I think that we're a little bit away from.
Yes.
But it's starting to become a little bit of a gray field, because a lot of people are talking about it in that way. And although the definition might differ technically, we're still thinking we're approaching that rather quickly. And if we're doing that, I think it's important to then also acknowledge that it's not the case that ChatGPT is that, of course. But what it then is and how it gets accepted into industry, what is and what isn't, for me, that's a very important question that we need to take care of, because although ChatGPT can do very awesome, interesting things, it's not factual information, right? Or
right.
It doesn't necessarily have to be. It's not always the case. And that's something to take into account when developing these types of models, and when we're looking at, these large language models that have billions upon billions of parameters that can do very interesting, very awesome things. I'm really curious to see how that would then fit into the AGI discussion. But I do think the coming year will be quite drastic, the way things are going now.
Yeah, I think that there's going to be another very exciting year for natural language processing, with ChatGPT and GPT-4 coming out in a couple of months. That will obviously be interesting. But yeah, there's definitely some sort of gap between true intelligence and creating large language models with billions or trillions of parameters. It doesn't necessarily translate into understanding. That's my take on it. I guess that sort of touches on things. My next question, which was going to be like, how has the field changed since you started working in the industry? Would it be the advent of large language models, or are there other changes that you've seen?
So when I started the large language models, or more when I started doing machine learning, the word-to-vec type of models were really coming up and showing the possibilities of those, and then slowly into the transformer type models, and from there, of course, we have what we have currently. I would say that the large language models really changed the entire field, especially when you consider what Hugging Face is now, right? With their with the amount of models that they host and the things that they can do. What I do want to say is that we see there's a huge trend going towards those huge, major, large language models that nobody can actually run on their own machine. And there's a very small piece of research going there, which is a little bit focused more on distillation and making it accessible for, you and me. Right. I have a laptop here that has an okay-ish GPU, but not much more than that. And I want to run these models without making use of an API. And that's not always possible because it's not that fast. And there's still a lot of research packages that go into that direction. If you take sentence transformers, for example, they distill it and make a very accurate representation of what it has been trained on quite fast. So the inference and the speed of using those models is really great. And I would love to see more of those instead of billions upon billions of parameters. Which is nice, though. Don't get me wrong. We need to have those to eventually get to a distillation or smaller versions. But it would be nice if there was as much attention as to the smaller models as there were to those larger ones. Because I can use the smaller ones. The larger ones are not really accessible to me. Right.
Do you see any connection with how generative models can affect something like topic modeling and BERTopic? Have you thought about incorporating it at all?
Yeah, that comes back to dependencies and things like that. But what I think Cohere has done is they created Topically, I think it's called. And that's basically GPT on top of BERTopic. So BERTopic generates, of course, a number of topics and descriptions of those topics by a number of words. And they feed those words essentially into a GPT model and ask to create a topic out of that. Just a natural description. And it does that really well. The issue with such an approach is that from a production setting, it's really difficult to run on your machine, right? You need to have an API, which is absolutely fine if you're using Cohere. It's an amazing service. But when you're running things locally without any internet connection, having a local GPT model is just not done. The moment these models are becoming very relatively small and doable on your machine, that's the moment I will start to integrate these into BERTopic. But if you want to, use GPT on a couple of hundred of topics, but slice that over, 100 classes, that becomes really difficult and really long to calculate all of these things. And that's the reason why I wouldn't want to integrate that into BERTopic right now. That's why what Cohere has done is amazing. It's something on top of BERTopic if you feel like you need it. Which is also something I would definitely advise using if you have that service or if you're interested in using that. But integration in BERTopic is a little bit too far ahead until performance reaches the state BERTopic is right now.
Right. That makes sense. I've experimented some using some of the outputs of BERTopic and putting them into some open source generative models, and have been pleasantly surprised sometimes.
That's great.
With the outputs. I think that's definitely going to be an interesting, future research. What do you think about like the hype that these new generative models are creating? Do you think there's a big gap between the hype and the reality? What's your sense on that?
Yes and no. It's an annoying answer, I know, but so no, I don't necessarily think there is a gap, because a lot of these models, let's take ChatGPT for example. It's doing or Stable Diffusion, maybe a little bit more interesting. So basically, from text we're creating images. That's amazing that we can do that. That's truly amazing. And there are people out there who are actually great prompters who know which words they need to use in order to create awesome imagery. And if you can use that in a very smart way, there are a lot of use cases where this might be interesting for mock-ups, for example, or when you're creating art for your game or something like that. There's still a gap in the sense that it's not exactly doing the things you want, right? You're still searching a lot of ways to make sure it gives you the output that you need. It's a very large model that doesn't run as fast maybe as you might want it. There's a lot of issues when it comes to artists being copied. Over the internet. Over the last few months, I've seen quite a lot of people who say, okay, somebody trained on my specific artwork and I was generating it as if it were mine. Well, that's of course not the way that we should go into. So I think there's a lot of hype that makes sense, but a lot of the hype is also as a result of something that's just fun to use.
Right.
Whether it's something that will actually be used in a lot of organizations, I highly doubt that. But there are certain use cases where I do think this will make a huge impact, but they're just a limited few. And for a lot of people, this is just something fun to use and something that's easy to go viral.
Right. Yeah, it's pretty unbelievable, the impact that ChatGPT had, getting over 1 million users in under a week. Interacting with it, it's definitely something special. I think they slow down the output, so it makes it feel like you're talking to a human. you know?
Maybe it also has to do with, I'm not entirely sure, just to make sure the people are still using it without querying it too much.
Right.
If it slows down the time you can actually query it. But I've been, even here in the Netherlands, there are a lot of people using it in Dutch, and it does it relatively well, and that's interesting to see, and I'm wondering when I will see it popping up in actual research and contracts that people are writing, things like that. It's amazingly viral.
Yeah. Have you used it at all to help you with anything, like even like a day-to-day thing?
Not much, actually, because it still requires me to correct it quite a lot of the times, and I'm somebody who likes to do it in my way. So, but I have been using it when I'm writing articles to come up with 10 titles for an article, for example, just to give me some inspiration and to feed off, and then I'll change it 9 of the 10 times.
Right.
But I do think it's an amazing way to get an initial idea of something that you want to create. If you want to create an introduction about federated learning, just type it in, it will give you something back, and you can change it the way you want it, you can adapt it. It's really interesting to see that maybe at some point we don't have to type all these things out ourselves. We just ask somebody or ask ChatGPT to do that, and then iteratively ask it to change it in the way that fits with what you're trying to achieve. So the way we're writing and interacting might change completely if something like this gets a little bit more open source or eventually more accessible to the public than just an API, for example. And that would be definitely interesting.
Right. Yeah, I think there's a certain amount of creativity in creating the right prompts for it. Yeah. And also, like, that sort of is the way that the future is going to be. It's this interaction that humans have with the machine to create the best output. To get maybe an initial idea, and then you could work off of it or modify it.
Yeah, that saves so much time in the process, also, right? I mean, you know what you want to write in many cases when it comes to, you're writing a paper and you want to write an introduction about. I call federated learning, but maybe it's stable diffusion, or maybe it's something else. Just ask somebody else to write an initial draft of it, and then you can change it. You already know what you want to write, and if you're an expert on the field, then the only thing you have to do is just go over it and check whether everything is correct and properly done. But it saves so much time. There's also risk involved in all of this, of course, is when people are using it and just copy-pasting it as is.
Right.
But eventually we will also find some way to deal with that.
Yeah. And I think an interesting aspect to it that sometimes, I don't know, maybe some people forget, it's that it's so powerful because of all of the information that has been created by humans. That's sort of laid the foundation for it. So I guess maybe just to switch things up, going back into machine learning. I didn't even know that we were going to be talking about ChatGPT, but I guess if we're going to talk about natural language processing, how could we not? But are there any people in the field that inspire you, that you're very influenced by?
So there are a few people that I follow, but I wouldn't necessarily say there are these people that really influence me tremendously. And the reason for that is kind of because of my psychological background is that I tend to look at things from as many perspectives as I possibly can, and that the same thing applies to people that influence me. So I try to take snippets of what people are saying and use that for what I think, okay, this is interesting. Because everybody has their strengths and their weaknesses, of course, and I focus on those strengths, but I take then 20, 30 people that I think, okay, these are awesome, these are great at that specific thing, and I try to combine them. So I started out learning, transformer-based models with the visualizations of Jay Alamar, for example. Who does,
incredible, classic.
Yeah, that's incredible, that's awesome, right? He's doing amazing work with respect to that. But that's one aspect that I take then from him, and then I take something else from somebody completely different. and use that. So it's a combination more of people than necessarily, okay, this is somebody that I think, okay, I love everything that person is doing.
Right.
Which seldom is the case because, we're people and we're not great at everything. So, this person is better at ethics, this person better visualization, if we have a coder. I'm a big fan of the sentence transformers library, for example.
Absolutely.
So that's one interview that's coming up with Niels. Amazing work, right? But if I want visualizations, I go to Jay. It's that combination of people, and I think you find them eventually yourself. Because I can say, here's a list of 20 people that I find interesting, but I find them interesting because I am who I am, and I look at things in a certain way. So I'm also trying to kind of support my way of thinking with views that support mine, right?
Right.
I'm still human in that way. So even if I give, these people, it might not fit with somebody else who just views things differently.
Yeah.
So I'm sorry, that's kind of a non-answer.
No, it's a great take on it. I like that. Any people outside of machine learning that inspire you?
Oh, that's a good question. I really like so I recently did with BERTopic that animation.
Love it. Yeah.
Thank you. I wasn't fishing for that, but it's welcome.
I still love it.
So I did that with the software of 3 Blue 1 Brown. And I really truly enjoyed that YouTube channel with mathematics in general and the way it's being visualized, and that there's even a major package on top of that that's open source that everybody can use. Those types of people I really enjoy following because they just give information in such a pleasant way that it feels like I'm just watching Netflix, right? If
Right.
you can do that. So Koersgezakt, for example, I did something quite recently, an article about that. That's also a channel that gives a lot of information about different types of subjects. If you can present complicated things in the way as if you're watching a movie, that's truly beautiful if you can do that. Yeah, I'm truly impressed with that. So maybe those types of people that
Right.
mostly influence me. Yeah.
What I found in data science and machine learning is that, there's the hard skills, right? And then there's the soft skills and being able to explain sort of the work that you're doing and having, blending in the psychology of it and understanding how people learn and how people think about things and how people perceive, and sort of understanding, what's the best way of saying this? What's the best way of visualizing this? It's so important because then you allow other people in, right? And then
Yep.
you can get their feedback, and then that's when I think things really start to kind of take off and can reach new heights.
Yeah. No, I fully agree. It's something that, of course I agree. I'm super biased in that way. But in this field, I really think that sometimes one really cannot exist without the other. Sure, I can create the most complex algorithm out there to do some sort of specific task. But if I cannot communicate that properly to my stakeholders, then truly what's the point? I see that in open source, where a lot of packages are really, really impressively done, but are really difficult to use. So nobody's using them, which is just a shame because there's not much thought put into that psychological aspect of it. But it also works the other way around, right? If I want to explain something technical to a person, a difficult algorithm, I really need to understand that algorithm really, really well in order to be able to explain it. So I can know how to explain it in a way that I know how to communicate, in the way to phrase things, in the way to capture an audience, but it doesn't actually mean that I understand the content. So it works both ways. It's always nice when people say, okay, you need to have soft skills, but in order to have soft skills, you really, really, really need those hard skills also, because if you don't know what you're talking about, well, you can bullshit your way out of it just a little bit, but
Right.
people will find out.
You need to be able to,
definitely.
you got to be able to back it up with the hard skills for sure. Yeah, for sure.
Yeah, and in some cases, I really think they're just as important. Not all cases, I mean, it's not that black and white, but if we're talking in the business sense, then you need to be sure that you're able to do your job, but then the rest of it definitely is selling it, saying to people, okay, this is worth investing to. And in order to do that, you need to explain it well, you need to attract people, and it's not always the case that you need to do that as a data scientist. Sometimes you have managers that do that for you,
right.
That abstract those things away from you, because there are a lot of technical data scientists out there that don't necessarily want to be focused on, you know, a lot of meetings and a lot of presentations and things like that, which is fair. But then there still needs to be someone who does all of the, well, selling, essentially. Yeah.
Right. Yeah, learning how to deal with all the different types of stakeholders, from, you know, a non-technical person to the CEO to the head of product to another data scientist. You know, it's so important, and sort of understanding who your audience is, and yeah, the best way of, you know, sort of getting your learnings across.
Yeah.
To get into the learning from machine learning.
Awesome name, by the way. Yeah,
thank
that's
you.
Great.
I appreciate it. What's one piece of advice that you've received that has helped you in your machine learning journey?
Yeah, for me, I don't necessarily know who I've gotten this advice from, but understanding the problem truly is the solution. I'm going to say that over and over and over again. If you really don't know the problem that you're trying to solve, there's no way you're going to get a good solution. And it seems really simple, but it's not. This is one of the most difficult things that you can do. And there are so few people that can actually truly try or truly understand the problem that they're working with. I'm working now, for example, in cancer research, and I have a lot of amazing colleagues, and there's one of them that really dives into the issue before coding, right? It takes weeks before really, you know, it still codes and still looks at what a potential solution might be, but spent weeks just trying to figure out what exactly is happening here, how the data looks like, what is the context in which it's being used, what are difficulties, how's the connection with legal, for example, which makes coding so much easier.
Yes.
Because you have done all of that footwork, right? And then you know exactly what you want to program, what you want to predict, what you want to solve. But that's immensely difficult because it's more than just a technical problem. It often also relates to, okay, how is the data being generated at all? You know, in most cases, there is some sort of, not always, but some sort of psychological component to it. Or there's some issue with the data, which is always the case. There's always some sort of, you know, dirty data out there.
Peculiar artifact, right? Like something's going on.
Exactly. And that really depends on the process. So you need to understand the process of data generation. But then if you're going to devise a solution, who are you devising it for, and why do they want that solution? Because what often happens is that people ask for a solution and they might actually mean something entirely different. It's not their fault because they try to communicate it, but because you are a technical person and you know what the possibilities are, you might say, okay, but then you might need to focus more on this in this direction. And that might happen, that if you don't do all of this, that eventually you push out a model where people say, that's not really what we're looking for. And then what you also often see happening is that they say, the one who created the solution, but you should have told me that before. That's not the way we should communicate, right?
Right.
I mean, It's a two-way street, and you cannot just tell somebody, okay, you need to tell me exactly what you need, as if you were a data scientist. You know, it doesn't work that way. We need to help each other. And understanding the process, understanding the problem, really is, I think, the best way to spend your time in data science.
100%. Sometimes just a pen and paper, right? Before you get into the code.
Yeah, definitely.
And then also, just to add on, I would say, revisiting the problem, right? Like maybe even after you start working on a little bit, then you start to realize, oh, you know, all the requirements weren't quite addressed just yet, you know?
No, that's perfect. That's amazing because, you know, it starts from the problem. And as you mentioned, going back frequently to see, okay, I'm still on track with what I perceive to be the problem at first might change later on when you start, you know, devising the solution.
The tricky thing about this sort of iterative process in data science is once you do sort of, you know, you kind of pick a solution at some point.
Sure.
It starts to narrow your vision, your vision field a little bit, right? So
sure.
That's why you always kind of have to go back, you know, understanding, figuring out what's this from a business standpoint, what's this from the data standpoint. Yeah, exactly.
Yeah, and it's okay if it becomes a little bit narrow over time. Of course, you start broad. Now you're trying to explore everything that's out there and eventually a solution. So it has to become narrow. But as you mentioned, not too fast. It should take some time. And it should, you know, it's like reinforcement learning. There should be a balance between exploration and exploitation.
Right.
You know, we're going to devise a solution, but we're still going to keep some room for some exploration of some different things to see if that still works or if that's still relevant or whatever.
Right. That upfront time can save you so much time.
So much time.
Yes.
It's,
so the next one, I'll ask it in two ways.
Sure.
Maybe it's the same answer, maybe not. What advice would you give to someone who is just starting out in machine learning or natural language processing?
So I would really start doing projects as much as possible. And it's, I'm really okay if it's just the Titanic data set or housing regression prices. I think that's the one. Sure, there are a lot of people who've already have done that, but getting your hands dirty is exceedingly important in data science because at some point you develop an intuition about certain things. You see a problem, you don't know exactly why, but you feel like, okay, this should be the solution. And that happens because, I mean, you're also a predictive model in a way. You know, that gut feeling, that's because you learned something before with the previous project where you found something to be working well or something that's very similar to what you're doing right now. And by doing all of these projects and by just getting your hands dirty and analyzing stuff, gathering your own data, cleaning your own data, applying these algorithms, going into depth, that helps you really understand the field, get that intuition about when something is working and when something isn't working. A famous example is what most people say when they're starting out is if you see a model that has a 99% accuracy, exactly, there's bound to be something wrong.
Oh, no.
That doesn't happen. Generally, It doesn't happen. So that's an intuition that you develop at some point. And this is a famous one, of course, but a lot of more of these are out there. And there's a lot of these that are have been implemented eventually into BERTopic because there were a lot of things that I felt like, there's something weird going on here. I'm not entirely sure, but I feel like I should look there and there.
Yeah.
You know, the only reason why I would do that is because I've had a lot of experience with a lot of these projects and I would know immediately where to look, even though it wasn't something I had already done before. I think if you're starting out, just do the work.
Right. That real world or the real project experience can sort of give you an idea what, you know, maybe where there might be a pitfall, maybe where there might be like a pothole, and that experience can kind of help you navigate, you know, a little bit better.
Yeah, definitely. And if you're really starting out, don't be scared of what people saying. Don't use Titanic data set and don't use housing regression. Everybody has to start somewhere, and it's okay to start with perfectly clean data. It really is. And then you can slowly build your way up to lesser clean data, gathering your own data, as stuff like that.
Right. So in a similar similar direction, what advice would you give yourself when you were starting out?
Oh, that's an awesome question. Oh, I really have to think about that. Ooh, that's tricky, because I'm drawing from my own experience, of course. And, yeah, maybe start in the field a little bit earlier. And what I mean with that is, I transitioned, of course, and because of that, I started in the field relatively late. There were a lot of people my age who already had 4 or 5 years of experience. And although doing a master is nice and definitely recommended, experience brings you a little bit further, I think. Maybe not a little bit further, but it's just as valuable. So if you can do both, that's amazing, of course. And I think what I never really truly had is a mentor in my years of data science. Not somebody I could always look up to and ask questions about the things that I'm dealing with. I had to discover everything for myself, and that has pros, but the main con, of course, it slows down some of the learning processes tremendously. So the advice I would have given myself is maybe focus a little bit less on academics during that time and a little bit more on getting that experience. Although by now I'm yeah.
Well, it's still good advice, and I like the advisor or mentor idea of that. I think that that's something that people tend to shy away from, but I don't think they should. It's an important thing that can help you along in your journey. Sometimes it's nice to do everything sort of on your own, right? And you kind of face the learning pains, and you get that real strong sense of accomplishment when you get it done.
Exactly.
But it would definitely speed things up if you had someone, even just a sounding board, to talk to.
Exactly, and a mentor can even do that, right? A good mentor sometimes will say, "Go figure it out yourself." Because a good mentor will know your capabilities and will know how persistent you are and what you can and cannot do. So he or she will know at some point, okay, if you spend a few more hours, I'm sure you will solve it, right? And if by then it's not possible, okay, I will nudge you in the right direction. But that's all you get, right? A nudge. That's something that would have made a huge difference for me, I think. Yeah, that's what a good teacher or a good mentor can provide. So to get a little philosophical or bigger picture, what has a career in machine learning taught you about life? Difficult questions. You make me think here. No, but really, for me, machine learning has came at the same point in my life, roughly as chronic pain, and dealing that was quite difficult. So finding a balance between a healthy life and the thing I really enjoyed most, machine learning at the time, that for me has been quite difficult, finding a nice balance between those two, because that chronic pain makes it for me difficult to type 10 hours a day, for example. So I really have to balance the way and the amount that I work. And that's tricky, right? So when you switch careers, that's already quite difficult. But then when you finally find something that you think, okay, that's it, that's what I want to do. And then at the same freaking time, you get chronic pain. That's not something that makes you that happy.
Right.
So for me, that has been has been very difficult, but it's been, in hindsight, a very valuable learning experience. Really, truly knowing what I stand for, what is important to me, what I want to focus on, to take a step back at times, because that's also the field of machine learning. It goes fast. It goes so extremely fast, and there's nobody that can keep up with everything that's happening there. But the fear of missing out it becomes tremendous, becomes huge when things like Stable Diffusion and ChatGPT and all of these things get released on I would almost say a daily basis. it feels at times. But I've really learned to then take that step back and to view the broader picture. You don't have to know everything. There are a few things that are more or less important than others that you can follow. But eventually you will catch up with whatever is happening. I mean, it's great that ChatGPT is doing so well, but I wouldn't have to have known it day one. If I weren't making some sort of business out of the model, there's no need for me to know it then. So I can give myself a little bit more space to find that balance. Although with BERTopic and writing and keywords, it's still difficult.
Yeah, I'm not sure how you find the time to maintain such incredible libraries and keep a day job.
I have no clue. I try my best. I'm not sure my wife is always that happy, but no, I'll make sure to find a balance between that. But you're right in saying, the day job combined with open source and writing is difficult. So maybe somewhere in the future I would love to combine that, but that depends. It's open source, right? It's maybe if some point there's an organization that says, okay, we're going to support that fully, then maybe that's something that's interesting to me at some point. But for now, I've an amazing job where I get a lot of freedom to also work around the chronic pain, which is awesome because there are not many organizations that provide that, and still work on the things that I think are important.
Well, your work is greatly appreciated by this machine learning scientist, and I'm sure many, many others out there. So just to conclude, if there are people who are interested in either reaching out to you or learning more about you, are there any places where they could go?
You can go on Twitter, on LinkedIn. Those are the main sources for me where you can find me. I have a website. It's maartengrootendorst.com, which only Dutch people can understand.
Okay.
No, it's just my name, but it's the way you pronounce it. I mean, it's not the easiest thing to translate into English. But no, Twitter and LinkedIn. Mostly LinkedIn, you can reach me there quite well. Yeah.
Awesome. Maarten, it has been such a pleasure talking with you. Thank you so much.
Thank you for having me. It was a great interview. I love those questions, really. Most of them are really technical, right? That's what you do mostly if you have something like keyword or BERTopic. But focusing a little bit more on the philosophical, psychological aspects of it is truly appreciated.
Absolutely. Thank you so much.
Thank you.